Benzene reacts with carbon monoxide and HCl mixture in the presence of aluminium chloride and forms benzaldehyde via an intermediate substance which is known as formyl chloride. Now let us look at the Gattermann-Aldehyde reaction. Benzene on reaction with the mixture of hydrogen cyanide and hydrochloric acid in the presence of anhydrous zinc chloride yields benzaldehyde. This reaction is known as Gattermann-Aldehyde reaction. Houben-Hoesch reaction. Resorcinol on reaction with alkyl cyanide and HCl mixture in the presence of anhydrous zinc chloride yields 2,4-dihydrous alkophenol. This reaction is known as Houben-Hoesch reaction. Here in the RCN, R may be alkyl or aryl group we can use. The intermediate involved in this reaction is formiminochloride, which is unstable. Now let us talk about the Reimer-tiemann reaction. Chloroform in basic condition produces unstable intermediate which is called as dichlorocarbon. This dichlorocarbon acts as neutral electrophile. When phenol is reacting with chloroform in basic medium, first dichlorocarbon formation takes place. This attacks on phenol ring, then yields ortho and para salicylaldehydes. Let us prepare from Grignard reagent. When Grignard reagent is heated with hydrogen cyanide followed by hydrolysis yields aldehyde, whereas the same reaction with alkyl or aryl cyanide yields ketones. Here first step is nucleophilic addition reaction. In alkyl magnesium halide, due to electropositivity of the metal, magnesium acts as positive dipole and alkyl group acts as nucleophile. If either alkyl magnesium halide or alkyl cyanide is excess, alcohol formation takes place. This due to further nucleophilic addition of the reactants with already formed product, that is ketone, which is already in the reaction mixture. Grignard reagent on reaction with acid halide and carboxylic acids also yield carbonyl compounds. Let's look at the equations. RMgX, that is alkyl magnesium halide, otherwise known as Grignard reagent, plus R-COCl is acid chloride, gives rise to R-COR with a Cl. When it is treated with magnesium halide, then it gives rise to R-COR plus MgXCl. So that is R-COR is a carbonyl compound. Similarly, RMgX, that is a Grignard reagent, plus R-COOH, that is a carboxylic acid, gives rise to R-COR single bond OH. When again treated with Grignard reagent, gives rise to R-COR, which is a carbonyl compound, plus MgXCl. Taking an example, CH3MgX, that is methyl magnesium halide, plus HCOCl gives rise to CH3C bonded to OMgX and H and also with Cl. This in turn gives rise to CH3CHO, that is acetaldehyde. Stephen's reaction. Aldehydes can be prepared by reducing alkyl cyanides with stannous chloride in the presence of hydrochloric acid followed by its hydrolysis. This reaction is known as Stephen's reaction. This reaction proceeds via a less stable intermediate called as imine. Next, we can prepare from alkenes on the name of Wacker's process. Acetaldehyde is obtained by passing ethylene through an aqueous solution of palladium chloride and cupric chloride. Acetone also can be prepared using this method, but by passing propylene gas through an acidified aqueous solution of palladium chloride and cupric chloride. Now let us prepare from alkynes. Acetaldehyde is obtained by passing acetylene through an aqueous solution of 40% sulfuric acid and 1% mercuric sulfate at 60 degrees Celsius. Here is the mechanism of the equation. This reaction is an example for electrophilic addition reaction. From water, H plus ion acts as electrophile and it attaches to the multiple bond of acetylene. Later, the O minus ion nucleophile attaches. Consequently, less stable enol structure forms, which on tautomerization yields acetaldehyde. When we use propene instead of ethylene in the same reaction, then acetone is obtained.